Alright, so I'm just going to talk through the problems that were on the back of the study guide for Unit 12. First off, you had to write number one, you had to write net ionic equations, and you had to identify if it was a redox reaction and what got oxidized and what got reduced. Okay, first off up here you have the the molecular equation. Alright, the spectator ion is going to be nitrate. Okay, because it's an aqueous compound on both sides of the reaction. Now, for your net ionic, you then write everything else that is left. Okay, so this is your net ionic equation right here. I went ahead and put the oxidation numbers. Zinc is a solid, so it goes from 0 to +2. Silver is a +1, it goes from 0. So therefore, my electron flow is going to just simply go, it's what I tried to draw down here. You always draw an electron from what got oxidized to what got reduced. My zinc was oxidized and my silver was reduced. Okay, that was the first one. Now, in second part, you then have potassium hydroxide as well as, there we go. Okay, potassium hydroxide that's going to react with hydrobromic acid. They're a strong acid and a strong base, so it's going to form water and a salt. Potassium and bromide are aqueous on both sides, so they are also your spectators. And here is my net ionic equation. And since this is my net ionic equation, the oxidation numbers do not change, so therefore it's not a redox reaction. Okay, just to show you again, acid bases are really double replacement reactions. Double replacement are almost always non-redox, whereas a single replacement and a multitude of other types will be redox as well. Okay, number two, you had to use electrons to balance the half reactions and then determine if it was oxidized or reduced. So the very first one, you had to add one electron on the right hand side to get both sides equal to 0. Since electrons were lost, it was oxidized. And then the second one, this time you have a 2- as your reactants over here for the fluoride. The fluorine has no charge, so you have to add 2 electrons onto the right side in order to get them both equal to 2-. It's also oxidized. And then finally for the chromiums, you had to put 1 electron as a reactant, which will allow chromium to be reduced from chromium 3 to chromium 2. Okay, 3 and 4 both involve the pH equation. When the pH, remember, is the negative log of hydrogen ion. So the first one, they gave you pH of 5.34. You had to figure out if it was what the hydrogen ion concentration was. You do that by doing the anti-log, so 10 to the negative 5.34, which gives you a final answer of 4.57 times 10 to the 6th, and you needed to put a capital M for molarity for your unit for this particular problem. Okay, number 4, you were given a hydrogen ion concentration of 1.34 times 10 to the negative 12. Again, this one you simply plug and chug. So you take the negative log of 1.34 times 10 to the negative 12, gives you a final answer of 11.9. This also would be a basic solution. I forgot to write that down, but that's the other thing it wants to know. It would be basic because it is greater than 7 on the pH scale. Okay, then number 5, this was simply going back to an equation where you have molarity as moles per liter. If you're given liters and you're given molarity, you can solve it one of 2 ways. You can plug and chug into the equation, get 7.8 moles, or you can start to get used to the idea that you can use molarity as a conversion factor and also get 7.8 moles. Doesn't matter which way you tackle it, you're going to get the same answer. Okay, number 6 is a titration. Now remember, when you do a titration problem, you need to write the balanced chemical equation to establish the fact that it's a 1-to-1 ratio or it's not a 1-to-1 ratio. So you do that by just writing your equation. So this first one is a 1-to-1. You're looking for the volume of hydrochloric acid that's at 2.0 molar to completely neutralize 55 mils of 0.75 molar sodium hydroxide. And you get the right answer of 21 milliliters of hydrochloric. And since it's a 1-to-1, you don't have to do anything. Okay, well then it says how much sodium hydroxide would you need? How much sulfuric acid would you need to neutralize the same amount of sodium hydroxide? Well, when you balanced chemical equation, it's now not a 1-to-1 ratio. You need, for every 2 hydroxides, you only need 1 sulfuric acid, primarily because it has 2 hydrogens. So in essence, you need half as much sulfuric acid, so you take 21 and you cut it in half, and depending on when you limit your significant figures, you either get 10 milliliters or 11 milliliters. Remember, if you write the equation, do M1V1 equals M2V2, and then accidentally multiply instead of divide, it's not a huge mistake. You showed me you were understanding all the steps. You just crisscrossed on the bottom. Okay, last but not least, we had our equilibrium expression. Here is the equilibrium expression for this balanced chemical reaction. The only thing, and I made a mistake, if you do not have a 2 in front of the hydrochloric acid on your copy, there should have been a 2 there. Okay, so you would have taken hydrochloric acid and squared it. Right there, I made a mistake, so I wanted to correctly do it on the answers. You're given the concentration, so you simply plug and chug. You should have gotten a final answer of 1.93, and you do not need a unit because it is equilibrium expression. Okay, I hope that helps, and good luck on the test.